welcome to the Roll-Up. Today's episode is based on an article titled, Will ZK Eat the Modular Stack? In this episode, we cover modularity, we talk about ZK proofs, and why the ZKification of everything is radically improving the scalability of blockchains everywhere. We talk about the evolution of the modular stack, how it unbundles the conventional parts of the blockchain, and we talk about ZK proofs and why they are transforming the execution and verification of blockchains themselves. I hope you enjoy this video. Sit back, relax, and enjoy the show. Before we get to today's video, please enjoy a word from our sponsors that help make the roll-up possible.
Fuel achieves higher throughput by utilizing a novel UTXO-based approach that allows for parallelized execution. This design significantly accelerates transaction processing, which enables Fuel to handle vastly more transactions than non-parallelized systems. Thanks to advancements introduced by Fuel, Ethereum rollups are set to be more powerful than ever before. And Fuel is not just enhancing Ethereum rollups, it's redefining them, making them faster, more scalable, and more adaptable to meet the needs of modern applications and developers.
Guys, welcome back to the roll-up. Today I'm rocking my modular haircut. Hans is rocking his ZK will eat modularity glasses. So that makes two of us. And today we're going to answer the question of, will ZK eat the modular stack? This was a post that Hans put out as part of Equilibrium about a month ago or so. And I read it. I thought it was really interesting. And so I'd like to unpack it a bit more with the man himself. So welcome in.
Thanks for having me.
Yes, sir. Yes, sir. So maybe just briefly, what is Equilibrium and kind of what are your core interests when it comes to crypto that kind of led you to the ZK eating the modular stack thesis?
Equilibrium is fundamentally, we do low-level protocol engineering. So we help protocols build things which are safer, faster, and more useful. That's kind of the fundamentals of Equilibrium. Over time, we've expanded to other areas as well. So today we have a fund which invests. We have also built a prover network called Gevolot, and then a Euro stablecoin. But the bread and butter of Equilibrium is still protocol engineering.
Cool. Yeah, we know the Gevolot guys pretty well. Have had quite a few conversations about them, about proving. They're always on top of it. So ZK eating the modular stack. You kind of came to this idea and came to this thesis. So I think I'm just going to start this off and just pose the question of, will ZK eat the modular stack? And then let's just dive into each part and kind of talk about this more specifically after we kind of understand the thesis more broadly.
Yeah, good question. There's really no short answer to this. The reason why we wanted to explore this crossover between ZK and modularity is that we saw two big trends really accelerating or continuing to accelerate. And one of them is obviously the expansion of modularity, so splitting things into smaller components and being able to experiment with like combining different components and in that way reducing the friction for new entrants. And the second part is really the ZKification of everything. So we've seen both currently existing ZK protocols expanding and developing. But on the other hand, you also see kind of non-ZK protocols integrating some part of zero-knowledge proofs into their protocols. So that's kind of the first observation where it started. And then what we really wanted to examine with this piece was which parts of the modular stack has ZK already penetrated and which potential problems could potentially be solved by introducing some zero-knowledge proofs to the mix. So that's kind of the premise of it.
Cool. And so you guys laid out two big ideas around modularity and ZK, being bullish on both of them accelerating, which I think that we share that thesis. But basically modularity enables more experimentation, more like parallel experimentation, innovation, kind of like this a la carte menu of creating blockchains. And then you kind of have this ZK idea of expanding this experimentation even further, which comes down to what you guys called expressivity and hardness. And so expressivity meaning like what can we create like confirmations, guarantees about in the stack, and then hardness being like how sufficient and how hard are these guarantees. And so maybe we can talk about how modularity is kind of pushing this experimentation forward, and then how you see ZK kind of like making it more sustainable and expansive as well.
Yeah, maybe if we take a step back before this. Like, computers in general are kind of designed to do three things. They store data, they compute over that data, and they communicate with other computers and humans. And the way we see blockchain networks is that they expand on this current computing paradigm by adding additional guarantees that these three things happen in agreed way. So that's kind of the premise of it. And then the two things that you just mentioned, expressivity and hardness, is related to these additional guarantees. So expressivity is really about what can you create guarantees about, and then the hardness part is how hard are these guarantees. Like obviously in today's world, a lot of it is a trust-based model where you trust a third party or an intermediary to honor the rules. Whereas with blockchain networks, we can have crypto economics or cryptography, which we'd argue at least are harder guarantees in that sense. And the way that we see modularity and CK fitting into this picture is really around if you have the two axes and then a kind of a trade-off curve along that. Modularity enables you to move along that trade-off curve in a faster way and experiment and kind of speed run experiments around designs around blockchain networks. And then what CK does is expanding the curve outwards. So providing us with harder guarantees and to some degree adding expressivity as well through scalability or limited privacy.
Gotcha. Okay, so it's like, all right, so we have modularity as a concept for scaling blockchains. It's like we can create better systems, more scalable systems. We can facilitate more experimentation. But then we can also do this in a way which is verifiably accurate. Like we can create this verifiable computation nature of the stack. And so you kind of see this as like the next logical step for modularity to kind of take into this ZK realm. So is this to say that like optimistic guarantees are not as important in the future, or perhaps are a bit more important now? Or kind of like, where do you see this current state of modularity, and then where do you see like when we have more ZK kind of enabled, where do you see kind of this idea of more experimentation or more expansiveness kind of coming from?
Cartesi is your home for app-specific rollups. At the forefront of developing new tools and platforms that enhance the capabilities of blockchain technology, Cartesi enables applications that are flexible and built to scale. Build on a full Linux environment and use traditional software libraries, but in blockchain development. Go to cartesi.io, that's cartesi.io, to learn more about building your own app chain today.
Good questions. I think regarding your first question around whether optimistic versus CK, it's really around trade-offs. Today, with the cost of CK being still relatively high, the proving that is, it's perhaps more attractive to some applications who are very cost sensitive to go with the optimistic route. But that also then has trade-offs in terms of like you have longer verification periods and all that. With the cost of CK coming down through both hardware acceleration and optimization on the software side, we believe that trade-off space is going to become more difficult to argue. So that's broadly our thesis, that zero-knowledge systems are going to become cheaper and faster. And when that happens, it's the role of optimistic systems in that case. The argument for them is weaker, in our opinion. I think maybe one important caveat is also that we're not modular maximists. We think that it serves important, it has important use cases and enables things which the integrated stack doesn't do. One of them being faster experimentation on the infrastructure layer or the infrastructure stack. But I think fundamentally there are some use cases which fit the integrated stack better and others which fits the modular. So ultimately, I don't think it's a binary choice of either or.
Yeah, I agree. We've been hearing a lot around once ZK is the end game, right? For interoperability from all these different chains, kind of settling it into one proof, into one kind of like global state, for messaging, for prover networks, for just a variety of use cases, and we've had quite a few people on the pod speaking about this. Kind of going further into this modular stack, like one notion that I've been trying to like push that is a bit of a misconception is that just the modular stack is just execution, settlement, data availability, and consensus. It's kind of like a misnomer here. And when I saw this article and read through it, I was like, okay, this guy gets it. Like, you guys understand, like, this is going to just be expanded dramatically. So maybe I'll pull this up here, where you guys have this updated list of what you think as the modular stack is in 2024, and maybe you can kind of talk us through how you guys came to this this kind of expansion of this 4 parts to this 10 plus parts.
Yeah, definitely. And funnily enough, I mean, some of the pushback we got for this article was about our more complex modular stack. So it's good to talk about how we came to it. The whole premise was really that I think the simple modular stack, the 4-part that's often used, is good as maybe as a simple mental model, but it doesn't really convey the complexity of modular system or the modular ecosystem today, because the fact remains that whether we like it or not, it has expanded a lot, and there are now protocols building in much more niche cases than before, or focusing on a much more niche use case. So how we got to this revised stack is obviously to some degree a subjective, like it's our approach. It's not necessarily the ultimate truth, but how we vision is really like it starts from the top, from user operation abstraction. That's like the layer that users touch, and then goes all the way down to kind of consensus settlement, security, and those things which are furthest away from the user in that sense.
Yeah, so it's like it's almost like the unbundling of like the modular stack is like you could have a monolithic stack right here, just like one little box. Then you've got like this unbundling with the simple stack, and it's almost like this is like the unbundling further of the simple stack into what has now been created over the last 6 to 12 months, more and more infrastructure. And I kind of see like one day all of these things will be, or at least a lot of these will be, a part of an option that builders have when choosing like a roll-up framework and choosing a RAS. Like you can literally pick all of these different things to build your chain.
Exactly. Yeah, that's pretty much how I think about it as well. So it's like if you envision that in a year's time you log on to a RAS platform and you want to build your own chain, this is kind of the buffet that you see. And then you can pick different components. So for example, for proving, you might want to pick Gevolot, or you might want to pick some other solution. Data publication, maybe you want to go with Celestia, Avail, EigenDA. So like there are different protocols building solutions for these small modules of the entire stack. And then what it really gives is the freedom for the developer or the whoever is designing the blockchain to pick and match these different modules.
Yeah, and I can literally name projects for each of these, like user operation abstraction. You've got like Socket, Particle Network, Shared Sequencer, Astria, Espresso. Then you go down to the execution layers. You've got all the VMs, and you've got data querying, you've got kind of like block explorers, Gold Sky, etc. Even like Dora. Proving, of course, you mentioned a couple, data publication, and then long-term state storage. We've got Kive, ETH storage, Jackal, some others. Of course, consensus kind of and data publication. Are you seeing those as still being the same? Like that's the same layer? Like is it, if it's a Celestia on data publication, then it's a Celestia on consensus as well?
Well, it depends a bit how you look at it. So you could have a rollup that uses Celestia for just data publication, but then settles to Ethereum. Or you could have a sovereign rollup that uses Celestia for both data publication and consensus. So I don't think it's necessarily that one module needs to serve, or one protocol needs to serve just one model. And we are seeing this to some degree that, protocols are starting to rebundle.
Enshrine more. It's like
exactly
the monolithic thesis and the modular thesis converge, and Rishi and Movement are calling this integrated. We're just calling it like a middle ground almost. It's like modular protocols will enshrine more and monolithic protocols will modularize more. It's kind of like this middle ground, this convergence.
Exactly, yeah.
Cool. So we've got this extended modular stack. Now, you guys went and did an amazing job of building us out what a ZK-ified modular stack looks like, which I think is super cool. So let's look at this more closely. Maybe you can talk us through some of these examples and why in some of these cases the ZK integrations could provide a better kind of solution than what we currently have, or at least why there are advantages to these ZK integrations.
Yeah, definitely. Are there any that you were particularly interested, just out of curiosity? Or did any catch your eye?
Yeah, I thought I thought the verifying correct encryption of mempool for sequencing was interesting. So maybe we can start there. And then also on the security side. And we could probably talk about the ZK-like clients as well for data publication.
Navigating multiple blockchains can be complex and cumbersome. Let's say you want to deposit into a lending market on Polygon because they have the best rates, but you only have funds on Optimism. So you bridge your funds to Polygon only to realize that you need Matic to pay for gas. Maybe you use a centralized exchange or you ask a friend to pay for the gas, but only then can you finish your transaction. In a chain abstracted future powered by Connext, this is not the situation. You can connect your wallet to any dApp from any chain with all the complexities of swapping, bridging, and depositing, all completely abstracted behind the scenes. Head over to connext.network, that's connext.network, to learn more about Connext's Chain Abstraction Toolkit.
Yeah, definitely. So the correct encryption of mempool, as far as I know at least, only Radius does this out of the shared sequencers. So it's kind of them trying to stand out with the feature, and by encrypting the mempool, what it's really trying to do is to avoid toxic meb. And how ZK is used in this case is it's just the user generates a zero knowledge proof, which proves that the solving of the time lock puzzle would then lead to a correct decryption of the valid transaction. So it's not like ZK is a feature of this bigger piece, but it's not fully. So it's just being used to prove that the encryption was done correctly.
Yeah, makes sense. That's the verifiable sequencing rules. Cool. On the security side, it's a little broad, mix between ZK and economic security. I'm curious what you were thinking there.
Yeah, that's it's a less scientific way to put put things. What I was really going after with this is that we're starting to see some protocols giving users, or users in this case being applications, the option to choose between economic security and cryptographic security, so CK. I think the one we highlighted in the piece is can't remember at the top of my head.
For the security, I think it was here. Shared security, merge mining, Eigenlayer, Cosmos, Babylon. Oh, Brevo's co-chain with the co-processors.
Yeah, that's right. Brevis is the one. So yeah, I think that the reason why they're doing this is obviously that the optimistic one, or the economic security, is cheaper today and more feasible. And this goes back to your previous question about optimistic security versus CK security. We think this gap is gonna close, or at least reduce over time, which then maybe it's not necessarily a question of mix between CK and economic security in the future. Maybe it's just that CK is cheap enough. We'll just use CK.
Yep.
But yeah, that's kind of what it's getting at.
Cool. And then on data publication, I know Celestia has been trying to bring on like ZK accounts and validity proofs, which people have been arguing that might put them in like competition with Ethereum for being like also a consensus and settlement. You also mentioned ZK proving data availability sampling. Maybe we can just discuss this a little bit and then kind of come back to the original thesis.
Yeah, the CK proving the data availability sampling, I think that's there was some discussion about that earlier. I'm not sure if there is active research going on anymore, but it's, as far as I understand, rather than each light node doing the sampling themselves, they just verify proof that that the data was stored correctly. So it's like an even lighter version of the sampling.
Cool. Well, I think from this idea of ZK eating the modular stack, there's a ton of projects that are working on this now, and also I think it's kind of closer than people think. And so yeah, I think what's going to happen first is this breakup of the stack, where RAS providers and rollup frameworks will start to offer 5, 7, 9 different options, and then those ZK options will start to come in over time. And yeah, we might just get this ZKified full modular stack. Everything is built with ZK, and in those options. Yeah, I guess how far away do you think we are from a ZKified modular stack?
I think it's hard to say. Hopefully closer than we think. Maybe it's useful to try to define as well, like what we see as the end game.
Yeah.
Like trying to answer the question, when has CK eaten the modular stack? The two things that we highlight in the piece is kind of that when all unnecessary re-execution is avoided. So that kind of goes to how blockchains work today, is that each node re-executes computation to verify that it was done correctly, whereas with CK you have a model of one executes and the rest just verify. So that's number one, and then the second one is around moving on from economic security to cryptographic security. So going back to our point about stronger guarantees, if we can increase the strength of the guarantees, then we can move further out on the trade-off frontier.
More experimentation, more fun for the on-chain degens.
Exactly, yeah. And I mean, a third one, which we don't really touch that much upon in the piece, is around privacy.
Mm-hmm.
Zero knowledge proofs are good for privacy in certain extent, but we believe that the full privacy, or I think ANOMA has this term, information flow control, which we actually prefer because it captures the essence of what we're trying to do more. Like the the idea is not that everything is just private to everybody, because that's not a very useful system. But it's more like the user has control to disclose certain information to others. Anyway.
Yeah. Privacy is like a less talked about aspect of ZK. It's like kind of gets thrown under the rug a little bit because of regulatory stuff, I think. But yeah, man, I appreciate you coming on and breaking down this article with us and kind of giving our community a short and sweet kind of primer on this stuff. So if they want to dive deeper, they can read the full piece. And just kind of generally, I think people will be excited about being able to see what's coming and be prepared for it, and also kind of look at who some of the players in these categories are. So yeah, thanks for coming on, man, and for putting together a great piece.
Thanks a lot for having me, and thanks for the kind words.
Cheers, man.